Hi, I'm Jay, and this is my presentation for my pattern rec project, which is titled Optical Character Recognition Using Deep Learning Approaches. So I am working with an character recognition problem. It is one of the most widely addressed problems in the domain of computer vision with countless applications in the real world. It is also one of the tasks that deep learning techniques have been pretty successful at. Um, so the dataset that I'm working with is a Google Street View house numbers dataset, and the problem is to optically recognize those images accurately, the digits that are present in those images, basically. And the data that I got from this whole dataset, it is present in two formats. I've tried and utilized both the formats to obtain good results, and so the dataset contains street view images of house numbers. Um, they're not similar to MNIST dataset in the sense that they are grayscale, and the number of images that they contain, it's just way too much than MNIST. It's like 600,000 images, and it's present in RGB channel, basically not grayscale. So as I was talking about two formats, the first format is a whole number containing multiple digits in a single image. The other format is a single image having a single digit. I've tried and create convolutional neural nets for both of these images and ran them pretty successfully. So the basic characteristics of both of these formats is that they have 32 cross 32 uh, in size, and format 1 is grayscaled, and the second format it's in three channels, basically red, green, blue. The tools that I used are Pandas for data preprocessing and sklearn for preprocessing as well. TensorFlow and Keras for modeling, Jupyter Notebook for serving and coding, Colab for the same and utilizing the GPU, Matplotlib for visualizing the final results. Additional tools that I used on my local computer are Anaconda for package management and virtual environment, uh, and PyCharm for debugging. So for the data pre-processing, for format 1, there are in total like 19,000 images available for training and 6,500 for testing and 6,500 more for validation. Uh, these images are already like pre-processed, but then I wanted to convert the inherent data type of the images, so I converted it most of them into float and the labels into integer categorical data type, which is like one hot encoding. So if there are like 10 classes, one of those class would be encoded as 1 and all the other classes are encoded as 0. And it's like basically a vector of 10 classes. For format 2, my side of pre-processing included splitting the whole data into train and test, then taking that data and shifting access to better access the image. So instead of uh, going to the last axis to access the image, I just shifted that axis to the first, so I can easily access image by their indexes. I converted the image data types as I did with format 1 and normalized all the images from the range of 0 to 255 to 0 to 1. I also encoded the categorical data type of labels, and this was done in a similar manner that I did for format 1, where it had like it's like one hot encoding. Then I split the whole training set again into training and validation. So I created model architectures for both the formats. Both of them are a little bit different. Both of them are vanilla convolutional neural nets, but then they have certain differences in the way that the layers are architected in them. Uh, so the layers that I've used is like any other convolutional neural net. It's like a convolutional layer, a max pooling layer, dense layers, and some batch normalization layers as well in there. I am using ReLU as the activation function in convolutional layers, and I'm using sigmoid in dense layers. The optimizer that I'm using is Adam because it uses past learning rates and varies the rate for each parameter. It also uses the gradients to speed up the training process, so it's like one of the best performing optimizers out there. Um, the output, the loss function that I'm using is categorical cross entropy on the output layer, which basically takes in the probability of a certain image belonging to any of the n number of classes. In our case, it's like 10 classes, and gives out a loss value for it. So I'm running the whole network for 75 epochs, and my batch size is 128, and I was able to attain some good results with this configuration. Now for format 2, I have defined a generator to get the data out of the raw data set, and I'm augmenting that data in the sense that I am rotating the image, I'm zooming in and out, I'm sharing and shifting channels and shifting them up and down just to have a more like augmented data set. Then to select a good learning rate, what I did is I updated learning rate after each epoch using one of the Keras callbacks, and based on that I was able to find an optimal learning rate for the convolutional neural net, which is around 10, somewhere between 10 raised to minus 2 and 10 raised to minus 3. Um, Here I'm also using Adam Optimizer as it is one of best in class, and the output layer again uses the categorical cross entropy loss function. Here I'm running 70 epochs with a batch size of 128, and the layers are as usual. There are a few convolutional layers, a few batch normalization layers, and max pool layers, and then in the end there are some fully connected dense layers. So my evaluation results stand something like this. For the format 1, my accuracy is around 91 to 92%. My loss is about 1.07. This is the test loss, which is basically close to the training and validation. For format 2, my average accuracy reached about 96%, and the loss is similar to training and validation, which stands at around 0.17. This is the graph for these are basically the curves for each and every digit that I predicted for format 1. I was able to create this graph because a single image contained more than one digits. So this graph was possible for format 1, but similar kind of graph is not possible for format 2. As you can see, the best accuracy that I'm getting is for the first digit because it has highest number of samples. It's almost reaching 1, and then subsequently all the other digits follow. For format 2, these are the training and loss curves. As you can see, after only a few epochs, the training pretty much reaches above 90%, the accuracy pretty much reaches above 90%, and the loss subsequently decreases. So this has been my presentation.